Last time, the last time when we had a class, we were doing patterns, but we didn't do questions based on patterns. Today we're going to be doing questions based on number patterns. Né? You see, I sent two pictures on the group. Those two questions. That's what we're going to be tackling. Né? Let me
Okay.
just do this. Okay, so for the first one, where's that thing? Okay, for the first one, it's question 2. So we're given. Tell me if you can see this now because I can't see my black thing, but
Um,
I just can you
where?
see?
Okay. Let me see. Yes, I can see it.
Okay, please also ensure that the thing that you are you using your phone to view this?
Yes.
Ensure that you've pinned my screen like throughout your whole phone. You can see my screen, not just on the bottom corner. Ne?
Yeah, I can see it.
Okay, great. So we're given an arithmetic sequence, right? It's an arithmetic sequence, right?
Oh, it's too bright now.
It's too bright. Oh,
Yes.
so you can't see.
Yes.
Let me just switch this thing off
Okay.
and like take it. Okay, wait, nah. Is it dark now or is it okay now? Yeah, it's okay. It's a little better, né?
Yeah. Yeah, it's visible now.
Okay. So we have an arithmetic sequence, and they're telling me us that the pattern is going. This is 5 plus 7 plus 9 plus dot 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 plus 93. So they made sure to tell us that it's an arithmetic sequence. From the notes that we sent, we know that the general term of an arithmetic sequence, how does it go? It's Tn equals to A plus bracket n minus 1 D, right? A being the first term of the sequence, D being what? The difference in between the sequence, and our N, it's just the position of the what do you call it? Position of where the term is. So this one, this 5, it has an N of 1. This 7, it has an N of 2. This 9, N equals to 3. So you understand the whole general form of an arithmetic sequence. So now for 2.1.1, they're saying, what did they say? They said determine the term of the general. They said determine the general term of the sequence Tn, sorry, in the form what? In the form in the form Tn Tn plus Q. Right? So if they say in the form Pn plus Q, don't let this throw you off, right? Because this is what we're going to have. Let's look at what. Are you still with me?
Yes, yes, I'm here.
Okay. So if we have
I'll
a.
just be muting. I'll
Okay,
just
no
be
problem.
muting because
Oh, no problem. So if we have a 5 and then we have a 7 and then we have a 9 all the way to 93, right? We know that with an arithmetic sequence, we have a common second, no, a common first difference already, right? Because if you say 7 minus 2, what is it going to give you? 7 minus 5, sorry, it's going to give you 2. If you say 9 minus 7, it's also going to give you 2. So you see, we have a common first difference, right? So this 2, it's going to be your D, and then your A will just be 5 because your A is the first term, right? So when you substitute in, this is now what you're going to have. You're going to have Tn equals to what is our A? 5 plus N minus 1. What is the D? 2, right? So we're going to have 5 plus, when you subtract outside, when you multiply the 2 into the bracket, now you're going to have 2n minus, this is 2n by the way, 2n minus negative 2, right? And then you can have tn as what? You'll have 2n, 5 minus 2, what is it? It's just going to give you 3 plus 3. So you see, you actually have it in the format that they wanted, because remember they said they wanted tn to be what? Equals to, let me see, they said it should be pn plus q. So you see, you have a number multiplied by n plus this. So this, it's in the form this, right? So you get that now?
Yes.
Okay.
Yes.
So number 2.1.2, let me just erase this. Um, let's look at what 2.1.2 is saying. So 2.1, oh, this is a long question. 2.1.2, they're saying, given the series,
Can
okay,
you please use a darker marker?
sorry?
Can you please use a darker marker?
The problem is I don't know where the darker marker is. Okay, let me look for it now, because I genuinely do not know where it is. Okay,
Okay.
let me see this. Let me see if this works. Can you see this better?
Yes, I can.
Because I
Yes, it's
can't see
better.
the black. Okay, I can't see the black one. I'm sorry, man.
No problem.
But if it gets worse, then we'll just move to paper. Let me just check.
Okay.
Just check up there. It's probably in the car. So now, actually, let me just go and look for it in the car. I'm coming, Nick. Oh, found it.
Okay.
Mm-hmm. Okay, now let's look at 2.1.2. Ne? So 2.1.2, they're saying, so remember the general formula for this question, we got it as what? Tn. Everything is in frame, right? Let me just, yeah, perfect.
Yes, yes.
So they're saying 2.1.2, we got our answer to be what? 2n, was it plus 3? Yeah, it was plus 3, ne? Okay, so they're saying the given series represents the number of kilometers that an athlete ran each week in preparation for the ultra marathon, right? The athlete ran 93 kilometers in the last week of training for the program. How long in weeks was the training program? Okay, so they're telling us that this thing that we just came up with, this series, right? It represents the number. Okay, wait, wow. They're saying that, okay, this thing, it represents the number of kilometers that an athlete ran in preparation for the ultra marathon. Okay, so this whole thing, it is going to give us the number of kilometers ran by the athlete. Ne? Let's note that. Let's just say no of kilometers ran by athlete. I hope that's how you write athlete. Okay, fine. So, and then after that, they're saying the athlete then ran what? 93 kilometers in the, sorry, the athlete ran 93 kilometers in the last week of training for the program. How long in weeks was the training program? So this 93 kilometers, you need to, okay, they gave us the 93, and now they want to know in terms of weeks, how long was the program, right? So they want to know the number of weeks, but they gave us the kilometers, the 93 kilometers. And remember that they said that this 2n plus 3, it's the kilometers ran. It's the, this formula basically gives us the kilometers ran by the athlete. So now they're telling us that now the athlete has ran this. Now they want the number of weeks, which means what? They have given us TN. They're now looking for N because they gave us what the TN is.
I see. I see.
You get that, né?
Yes.
Okay. So now when you, okay, so now when you try and find out how long in terms of weeks, you need to substitute this 93 kilometers because we're being told that in the last week, the distance that he had covered was 93. So we want to know how long in terms of weeks did it take for him to cover this 93, right? So we have Tn equals to 2n plus 3. Remember, they said this whole thing, it gives us what? The number of kilometers ran. And currently, they gave us this 93. So, this 93, what is it going to be? Is it going to be our Tn or our N?
It's, it's going to be our N.
No, it's not going to be our N. Because remember, in the question, they're saying, remember 2.1.1, we just got this general term, right? And then
Yes.
let's read through the question. Um, in the
What
question, they're
is the
saying,
question in the group?
sorry?
Is the question in the group?
Yeah, I sent it to the group. It's 2.1.2. I think yeah, I did send it to the group before class started.
I cannot see. I see the link to the meeting.
You see the link to what?
To the meeting. I cannot see the question.
Oh, where did I send it now? Hey, oh my goodness. I don't know where I sent it. Sorry, ne. Let me just send it.
No problem.
It's this one. It's yeah. We're currently doing this one.
Thank you.
Okay. Okay. You saw the question, ne?
Yes, I see.
Okay, that was my mistake. So from okay. So 2.1.1, 2.1.1, yeah, it was saying just determine the general term, and we got this as the general term, right? Fine.
Yes.
Now I'm saying for 2.1.2, they're saying the given sequence represents the number of kilometers that an athlete ran in the program. So if they're saying that the given sequence it represents the number of kilometers ran by the athlete, look at this thing there and think of it as y equals to 2n plus 3. Right? This could also be your x, but we're not there. So if they're saying that the sequence, they just mean that this it represents the number ran by the athlete. So if you were to get y equals to 50, it means that the athlete has ran 50 kilometers. The y in this case it's our 50 kilometers, right? So in this question they're saying that the athlete has ran 93 kilometers, and they're telling us that this sequence it represents the number of kilometers ran by the athlete, right?
Mm. Yes. Yes.
Okay, cool. So since when we know that this tn, which is our y, if you look at it in another eye, it represents the number of kilometers. It means that this 93,
Mm.
it will be our Tn.
Oh, I see. Mm.
Okay.
So we are looking for the week.
We're looking
We're
for,
looking for N.
we're looking for n.
After. Mm.
Okay. Hi Kumalo, we are doing question 2.1.2 ne?
Afternoon.
Hello.
Hello.
Just go to the group. We have 2.1.2. We are, yeah, I sent the paper. We're doing 2.1.2. So now they're telling us that he ran 93 kilometers and they now just want the number of weeks, which means that the number of weeks will just be what? It will be, wait, let me check. The number of weeks will just be our what? Our n, right?
Our
So
N.
over here, you're just going to substitute. So you're going to say, in place of tn, we're going to say 93 equals to 2n plus 3. Then from over here, we know we're going to transpose the 3 to this side. So we're going to have 93 minus 3 equals to 2n. Wait, let me do this. Let me do that. Right? So we have 93. We're going to have 90 equals to 2n. And then for the subject of the formula, of course, we want n to be alone. So what we can do, sorry, what we can do is divide both sides by what? By 2.
I see.
Therefore, our n will be 45. So
45.
therefore, we have 45 weeks of training by the athlete.
Mm.
You see that?
Yes.
Okay. So yeah, that's the question. Let's look at 2.1.3 now. So they're saying the athlete used this opportunity to raise funds for her high school, right? The community sponsored her 10 rand each. Okay, the community sponsored her by what? This is 2.1.3. They're saying that the community sponsored her by R10 for each kilometer ran during the training program. R10 for each kilometer, ne? Let's just say each km. Okay, fine. Ran throughout the program. Calculate the total amount that the athlete raised for her school. So, okay, this is an arithmetic sequence. If you have an arithmetic sequence and you want to know the sum of the sequence, there's a formula that you can use in order to get the sum of the arithmetic sequence. Because they're telling us that this athlete, how long did this athlete train? The athlete trained for 93 kilometers, right? Which was what? Which was 45 weeks. So from the previous question, we noted that this 93 is going to be our Tn, and this 45 is going to be our what? Our N.
Oh, N.
So in order to find the sum of an arithmetic sequence, You're going to say Sn. This Sn is just means sum, ne? Nothing crazy. It just means sum. It's going to be Sn equals to n all over 2 all into n plus 1. Okay, so this n over here and this n, they are just going to be this, the 45. You get it? This is just the equation to calculate the sum of an arithmetic sequence, right? So you're going to have Sn, it will be equals to, what is our n? It's 45, right? So it will be 45 divided by 2, divide all into 45 plus 1. So over here we'll have 45 divided by 2 all into what? 46. Right. Now let me put this into my calculator. Let me see what I have. Mm. Wait. Wait, nah. I need to see something. Um, sorry, let me just. Mm, what is this? This is math. Grade 12. Fuck. Mm.
Hello?
Yeah, wait, now I want to do something. Wait a minute. Mm. Okay. Come back to this question. Uh, Come back to this question, ne? Fine. I made a mistake somewhere by the formula. We know that our TN, it was what? 93. Remember, in our series, what are we given? We're given 5 plus 7 plus, was it 9 over here? It was 9, ne?
Yes, it was nine. Yes,
Plus all the way to, what is this over here?
93.
93. So fine. In this question, they're saying that they gave her 10 rand per kilometer that she ran, right? So I would say, in order to
Yes,
calculate the sum of this question, what you need to say now, you're going to say Sn equals to n divided by 2, close bracket, n plus, this is like an L, right? It's not a 1, it's an L. Ne? Beware of this. And now let's define every term. N is just going to be your number of weeks, right? Which was n equals to 45. And then you might be wondering, now, what is this L? This L over here, it's going to be the last term.
Can you shift on
It's
the
the
other
last.
side? I can't see properly.
Okay, wait. Oh, let me just.
Yeah, thanks.
Can you see now?
Yeah, thanks.
Okay. Now this L is going to be the last term of the sequence, right? Of the sequence. Even if you go down to your notes, like you'll see this. Ne? I just wanted to rectify that. So in order to get our Sn, we're going to have Sn equals to, what is our N? It's 45, right?
it's 45. Yes,
Exactly. So our N will be 45 divided by 2, all into 45. What is our last term of the sequence now?
93.
93. 93. Right. So our Sn will be equals to, you just put this into your calculator. 45 divided by 2, uh, all plus 45 plus 93. Which is 3,105.
Yes.
So you see, this is the total in kilometer that she has ran. You understand? But now this is the total. They said that per kilometer she was given what? 10 rand. So per kilometer, she was given 10 rand. So this is the total that she has ran. So in order to get the amount of money that she got, I guess she ran 3,105. So in order to get the amount, you know that per kilometer that's in 3,105, she got the 10 rand. So you're just going to say 3,000, right? 105 times
Times
10.
10.
Yeah. So you're going to say 3,105 times 10, which will just give you R thousand 31,050. Which this thing is running out. I think I'll use the other one. But do you understand this question?
Yes, I understand.
Okay. Now let me see what the other one is saying. Mm, okay. Oh my goodness, I made another mistake. I'm lying. Over here. Ish, 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 ish. Yeah, over here. Ah, sorry guys. I don't know where my head is. Just erase this. Askies. Askies. Your SN, screw this again. For the last time, I swear this time. Your SN, it is actually N divided by 2 all into A plus L, not N. I made a mistake by saying N and N here. It's A. So we know that A, it's the first term, right? And L will be your last term, right? And then your N is going to be your 45. So instead of what we just did right now, we're going to have 45 divided by 2 all into what is our A? 5. Which is 5. 5 plus 93 ne, equals to,
Yes, 93.
yeah, so it'll be 45 all over 2 plus 98 all into, sorry, all into
93.
90. Because it's 93 plus 5, remember?
Oh, oh, I just
Yeah.
punched it.
Oh, yeah. If you say 93 plus 5, it'll give you 98. So your answer will actually be 98 multiplied by 45 all over 2, which is giving you 2,000 what?
2,205.
100 and?
2,205.
Oh,
Eh,
2,000. It's giving you what?
205.
2,205.
205.
So the amount, yeah, this is the sum that she ran, right? So now, in order to get the money that she got, you're going to say 2,205 multiplied by 10 rands, right? So your answer will now be what? 2,205 multiplied by 10, which is 22,050 in rands. So this is your the money that the community is going to give her. Ne?
Yes.
Okay. Now let's go to another question.
You have another question similar to this one.
Um, yeah, but let's finish this one first, and then we'll do another one. We're doing two, ne? We'll do two.
Yeah.
Uh, Okay, now back to the question again. Where is it? Where is it? Okay, so now they're saying the general term of a geometric sequence is what they gave us. Sorry.
Tn
Yeah. So they said it's T n
n
equals to
is equal to 2 to the exponent n plus 2.
n plus 2, right? And then what are they saying in the first question? The first question they're saying what? Write down the first term. So if they gave us that T n plus 2 is the general, it's the general sequence
Formula.
of this pattern, right? And then they say they want what? The first term. So what do they want? They want our T1. Let's say we have T1, T2, T3, T4. This is what they want, right? They want to know the number of T1. What do we know about T1? We know T1 occupies which position? N equals to 1, right? So in order to get our T1, we will just substitute here in place of our n, because remember, what is our n? Our n is just the position that the term occupies. And in this case, it's the first term. So it's the first position, right? So it's going to be n equals to 1. So we're going to say all equals to 2, all into 1 plus 2. So we'll have 2 raised to the power what? 1 plus 2, it'll give us 2 raised to the power 3. Right? So ooh, our T1, what will it be? Can you say 2 cubed? Will it be 8? I think it's 8. 2 all raised to the power 3. Yes, my
Yes,
calculator
it's
is
8.
giving me 8. So our T1 will be,
8.
our T1, it will be 8, right?
Yes.
And now, so if we have T1 is 8, let's look at what question B is saying. So question B, they're saying, calculate what? They're saying calculate. Let me see. Calculate the common ratio.
Common
Remember,
ratio.
for a geometric sequence, if we have T1, T2, T3, T3 divided by T2, it's just the same thing as T2 divided by T1. They should yield
1
a common ratio, ne? Okay,
ratio. Yes.
so just erase this. Okay. And because remember, we just said it will be Tn, T2 maybe, divided by what? T1. I need you to notice something. And then we have T3 divided by T2. Notice what's happening with these ends, ne? The thing that you should notice is that the T that's in the numerator, it's in the form Tn plus 1, and the one that's in the denominator, it's Tn. Because over here we have T of 1. In the numerator, we have T of 1 plus 1, which now gives us 2.
I see.
You see that?
Yes.
Okay. So we in this question, let me go to the question. Uh, what is this? Okay, so we will have same way here because they're saying, what did they say? Calculate the common ratio, ne? Find the common ratio. So we know that we will have, this is another question, this is B, right? We'll have Tn plus 1 all divided by, I think I should switch to pen. Let me see if this thing can write over here. But it's very light. Let me switch to paper. Ne?
Okay.
Just switch to paper. Ah. Sorry. Okay. Yeah, this is way better. So number B, you'll tell me if you can't see my screen or anything. Ne? Number B, they're saying we should find the common ratio, right? So now we just said that the common ratio, it will be given to us by Tn plus 1 divided by Tn. You understand that? So it means that in this
Yes.
term, because remember, in the actual question, they said that the geometric sequence, what is it given to us by? It's given to us by T, I think it was N plus 2, if I'm not mistaken. Ne?
Two. Yes. Yes,
Okay,
it's that.
so yeah. So now what we can do in this question, because we have Tn plus, we have Tn plus 1 divided by Tn. What we can do is we can replace the n with n plus 1. Okay, so now for our Tn, let me see, somebody's trying to join.
I'm so sorry. I pressed by
Oh,
mistake.
oh, no problem. I was wondering because you've been talking. Next thing you're not in the call. Okay, I'm saying, yeah, for the first one, we can replace the n with n plus 1. So what we're going to have now, we're going to have t all into n plus 1 plus 2, right? And what will it give us? It's going to give us t n plus 3, right? And then for the second one, because it's just tn, we're going to replace n by just n plus 1. So it will just be 2 raised to the power n plus 2, right?
Yes.
And now
Yes.
if we have this, because this is our Tn and this is our Tn plus 1, this is our Tn plus 1, right? We said that the ratio is given by this. So if we have our Tn plus 1 as this, now over here we're going to have T all into n plus 3 all divided by 2 all into what? N plus 2. Now from here, we can see that what? We have the same basis and we can just employ the laws of exponents. Remember, if we have 2 raised to the power a divided by 2 raised to the power b, the laws of exponents, they tell us that when we are dividing the same bases, you can just what? Subtract the exponents. So t 2a 2 raised to the power a divided by 2 raised to the power b. Because they have the same basis, you can just rewrite them as 2a minus b. Same way over here, we have 2, it's a fraction, but we have two things whereby the bases are the same. So we can just say this will just be Let me rewrite it here. We have n plus 3, right? Divided by 2n plus 2, which will just be what? 2, what? It will be n plus 3 minus the exponents that coming from the denominator minus x plus 2, right? So now let's remove everything from the brackets. So we'll have 2n plus 1, sorry, n plus 3, my mistake, minus n um minus 2. So because we have 2, these two will cancel one another. This and this will cancel. And then now you're left with what? 3 minus 2. What is 3 minus 2? It's just 1. And
One.
anything raised to the power 1, it will just be 2. Because even if you put it
Two.
into a
Yeah.
calculator, 2 raised to the power 1, it's just 2, right? So it means it's just 2. So our ratio, it is what? 2.
Mm.
Do
So
you
I
get it?
understand.
You
Yes.
understand? Oh, okay.
Yes.
Beautiful. Let me go to the other question.
Is it also okay if we use the general formula we've been given and then just put the n, and then after that, after finding the pattern, you just say term 2 divided by term 1 equals to the ratio.
Yeah, it would work because let's say you just say, I get you have T1, T2, T3, right? You know that this is n equals to 1, n equals to 2, n equals to 3. Let's say over here, you just say T3. Let's see. Is this what you mean? Like T3 plus 2, and then you say
I mean,
divided
like,
by, yeah, it would
I
work.
mean, uh,
Because
because
if you
I'm
have,
used to doing
oh, you're used to doing it that
I'm
way.
used to
Yeah,
doing
then,
that, but I also want to learn your formula as well.
yeah. So even this, it's going to work. I think this one is even shorter and nicer because you'll just have Tn plus 2, and you just, for your ratio, you know it's supposed to be T, the higher one. So it'll be just T3 plus 2 divided by T2 plus 2, which will just give you T to the 5 divided by, so why do I keep saying t? 2 to the 5 divided by 2 to the power 4. And we have the same basis. Again, we go at it. We say it's 2, 5 minus 4, which will just be 2
Oh,
always to the power 1, giving you your ratio as 2 again. So yes, definitely.
okay. Thank you.
Okay. Yeah. So let's say, so
Hello?
we have our common, yes, Kumalo.
Hey, I can see clearly. Oh,
Candidate, can you
I don't know if I'm the only one.
um is he the only one, or can you see, or you also have a problem? Okay, tell
A
me
bit
if this is
blurry.
better.
The lighting is making
It's too much.
um
Okay,
yes.
so let me switch it. But this is better, ne?
Can you please bring it closer? The
Yeah.
pixels are small, so it's hard to. Yes,
Like this. How is it?
yes, it's more
That's,
visible.
it's more visible. What is this? Okay. Kumalo, how is it now?
Ah, it's better now. I can see.
Oh, okay, cool. So yeah, we have our common ratio being what? Yeah, I think this is way better. Being 2. Ne? So now they're saying, let's look at question 2.2.2. So we know that our common ratio is 2. We know that our Tn is given to us by 2n plus 2, right? Now let's see what they're saying. Okay, number 2.2.2, They're saying calculate T20, write your number as a power of 4. I mean, if they just say that's 2.2.2, if they're saying calculate T20, this 20, what is it? It's our n value, right? And it's simple because we're already given the general term. So it's just going to be n plus 2. It's a matter of you substituting n, right? So you're going to
Yes.
say 2 raised to the power what? 20
20
plus 2.
plus
So
2.
now you'll have 2 raised to the power, sorry, 2 raised to the power 20. Sorry. 22, sorry, not 24. Let me just properly write that. Okay, so now that we have 2 raised to the power 22, they said that calculate T of 20. But what? They have a restriction. They said as a power of 4. You get it?
Yes.
So the answer that you're going to have here, it should be as a power of 4. So we have 2 raised to the power 222. Right? Let me see something over here. 2 raised to the power 2 2. Okay. 2 raised to the power 2 2. It's what? It's it's a big number. It's another big number. It's like, I think it's like, it's
It's
4194
only
304. It's a very big number.
304.
But they didn't say we should like give the solution in this manner. They said give the solution what? As a power of 4. We know that 4 can be written as what? 4 can be written as 2 all raised to the power 2. Right? If you say 4
Yes.
equals to shift fact, and you just want your 4 to be written in terms of 2, it will be 2 squared. Right? So now we know that 4 equals to 2 all raised to the power 2. What can we do with this? How can we get this 2 raised to the power 2 to become 2 raised to the power 22? What you can do is that you can say, you know that if you have, let's say, 2 raised to the power a multiplied by b, what is this going to be? This b is going to multiply into the power, which is a. So now we're going to have 2ab, right? So we're going to try and rewrite this 2 raised to the power 2 in this format, right? So we have 4 equals to 2 raised to the power 2. We just know that they said as a power of 2. So this 2 raised to the power of 2, it's 4. It's as a power of 4, right? So how we can rewrite this 2 raised to the power 2 as so that it can give us 2 to the 22, we can multiply outside by 11. Because if we say 11 multiplied by 22, it will give us, no, if we say 11 multiplied by 2, it will give us the 22, right? What I mean by this is that you can rewrite it as this. You can rewrite it as 2 raised to the power 2, close your bracket, all raised to 11. Because if you say 2 times 11, it's going to give you 22, and we are back here. Do you understand
Mm,
it?
yes.
Okay. So now, because they said they wanted it as a power of 4, you can rewrite whatever that's inside this bracket. Because what's inside this bracket, it's just going to give us 4, right? So you'll just write 4 all raised to the power 11. Because if you say 4 all raised to the power 11, it's equals to this number that we got for 2 raised to the power 22. So you just rewrote 2 to the power 22 as a power of 4.
Oh,
Do you
yes.
understand it?
Yes.
You sure? Are you sure that you understand it? Okay. Now let's move on
Yes.
to the next one. Right, okay. Now let's move on to the next one. Eh? The next one, we have sigma. The same calculate sigma n equals to what? N equals to 1 all the way to infinity of 1 all over Tn,
Yeah.
right? Remember, we're given Tn as
Hello.
just what is, yes?
Uh, when you are done, can you please take pictures for the other one? Because I was still doing the sigma one. I didn't notice. Sorry.
Oh, no problem. Just remind me, ne? Just remind me.
Okay.
So we're given Tn as n plus 2. So they want the sigma of this Tn, right? So remember from the which one, which question was it? What did we calculate our first term in this sequence?
Yeah, we calculated
What was the first term? We got
8.
T1 as
It was 8.
T1 is 8. Okay. Guys, I'm coming there. Somebody's knocking on my door.
Okay.
Yeah. Please talk about this in the meantime. I'm coming.
Hello, are you understanding?
Yeah, I'm understanding. What about you?
Yeah.
Okay, on this sum to infinity, according to how I understand it, they say it 1 over Tn, which means the sum of 1 over Tn. You can say 1 over 8 plus the second term was 16, 1 over 8 plus 1 over 16 plus 1 over 32, all like that. Then you can calculate the sum to infinity. It will be sum to
Mm,
infinity is equals to 1 over 8 all over 1 minus 1 over 2. Our common ratio will be 1 over 2 now.
I hear you.
Do you understand?
You can explain further.
Okay, since our first terms which are added, it will be 1 over 8 plus 1 over 16 plus 1 over 32, which
Oh,
which are
you
given by
computed
1.
the pattern.
Yes. Sum to
Oh,
infinity is
okay.
equals to a over 1 minus r. Then
Yeah.
our first term is 1 over 8
Oh, okay. Yeah, I see.
all over 1 1 minus 1 over 2. 1 over 16 divided by 1 over 8 is 1 over 2.
Okay.
Then you will get 1 over 4.
Oh, you divide them.
To get the ratio, r is equals to T2 over T1. 1 over 16 over 1 over 8 will get 1 over 2. Then you substitute 1 over 2, which is r, on the sum to infinity formula.
Isn't R2?
Hello?
Isn't our ratio 2?
If you take a good look at it, they say 1 over Tn. So what does that mean? 1 over 2 to the exponent n plus 2, which means on the bottom, our ratio is 2. But we can see that they say 1 over Tn, which means our new ratio will be 1 over 2. Do you
Oh,
Okay,
it's
I'm
understand?
back.
basically a fraction inside the fraction.
Yeah, you can continue.
Okay.
Okay.
Thank you.
No problem.
Okay. So now let's look at. Okay, what did you say so far, Kumar? So I can build on what you
I
said.
was explaining the sum to infinity that our new
Yeah.
ratio is supposed to be 1 over 2
Mm,
because 1 over Tn, it means Tn, it is 1, oh, it's the same as 1 over 2 to the exponent n plus 2. Then T, it will be 1 over 8 plus 1 over 16. Then to get
mm,
R, we'll say 1 over 16 divided by 1 over 8, which is equals to 1 over 2.
yeah.
Then,
Okay. So far, do we both understand that our first term, which is T1, will be 1 over 8, and our common ratio will be 1 over 2? Do we both understand this?
yeah,
Yes.
Yes.
Okay, fine. Now let's do the sum to infinity. Excuse me. Sum to infinity, it is going to be given to us by what? A divided by 1 minus R, which is our ratio and our term 1, our first term.
Okay.
Right? So we will have the sum to infinity being equals to what? What is our ratio, Ghana? Or our, not our ratio, our first term. We got it as 1 over 8. This is
One
the
over.
equation to the sum to infinity. This is how you calculate for the sum to infinity. Ne? This is the
Okay.
standard equation. So the 1 over 8 divided by 1 minus common ratio 1 all over 2. Then in order to get
Two.
your sum to infinity, you have to plug it into your calculator. Can you plug it into your calculator?
1 over 4,
1 over?
4.
Okay. Uh, 1 all over 4. Are we all getting 1 over 4?
Yes.
Yeah.
Oh, okay, beautiful. So, yeah, I think here the trick was just having to understand that here, since they gave you 1 divided by Tn, you're supposed to take your n down. And once you have your n down, um, you're going to have 1 all over 2n plus 2. And once you take it to the top, it will just give you t negative bracket n plus 2. Right? And now, in order to get your first term, which is number 1, you'll just say 2 raised to the power negative 1 plus 2, which will give you what we got, right? Your Tn, which is your A. And then, okay, let me just not use hypothetics. You'll just say 2 raised to the power negative 1 plus 2, which is, what did we get?
We got
The answer,
1/8.
the 1 over 8, right? And then in order to find the common ratio, you'd say T1, which is what? Um, if you say T1, it'll be just you substituting 1 all into 2, 1 plus 2, which we got as 1 over 8. And then for the second one, we'd say T2 equals to 1 divided by 2 all into what? All into 2 plus 2, which is 1 all over 16. And then once you divide this one and this one, you will get the common ratio that we got. And once you have once you have A and the common ratio, it's easy to just substitute here. Right? I don't know. Yeah, I don't remember if this is given to you or you have to remember it. But yeah, the trick was just in being able to take down your Tn plus 2 to the denominator. Right?
Okay. Yes.
So let's do the other one.
The other
Um,
one. The other one is, it is it is not friendly, shame.
okay, let's see what it's saying. The other one. It's 2.2.4, ne?
Yes. Hello, before you start, can I have a suggestion?
Okay. You guys want to
Can
try it then?
can you please give us a mark allocation for
Okay, the mark
for each
for,
for each and every for each, this was just a suggestion, for each and every
yeah.
question, so that you'll get used to how they mark, because sometimes you'll miss an important step and lose 1 mark or two.
Oh, so I should show the marker locations.
Yeah, I think
You
that's
want
what I
me
think.
to? Okay. Oh, damn. Thing is, I'm not. I don't have the memorandums, but I hear what you're saying, so you can know what they're marking, ne?
Mm.
Okay, okay. I think for future reference, I'll do that. Once I get a paper, I'll try and look for the memorandum as well.
Okay.
Because the mark allocation is there. I think you want specifically to know whether what they are marking, right? Like this and this and this. Because on the question that I sent, I think this was, if I'm not lying, on the group. Gore, it's out of how much it's written. Yeah, it's, yeah. When you see, when you, because 2.2.3, the sigma one, it's 3 marks. You can see that it's 3 marks, you know. I'll just try and always look for the memos as well.
Okay.
Ne? Yeah. It's
Yeah.
just that unfortunately I don't have a memo now. Okay, now let's look at 2.2.4. 2.2.4. So for 2.2.4, they're saying consider the first 21 terms of a sequence. So we go from n equals to 1 to n equals to 21. Sorry, not. Consider the first 21 terms of a sequence. Tn equals to Tn plus 2, right? And what are they saying? Calculate the sum of the terms in the sequence, in the sequence that are not powers of 4. Ooh, yeah. I get why this could throw you off. So they're saying Tn equals to 2n plus 2 is what it's the formula, not formula, man. It's the, what do you call it? The general term, right, of the sequence. So they're saying we should look for what? Sum of terms that are not powers of 4. Okay, so in order for a term, let's say you have, so in order for a term to be a power of 4, its exponent, like it has to be an exponent of 2. Like a term is a power of 4 if its exponent of 2 is like even. Do you sort of get what I mean?
Yeah, like for example, 2 to the exponent 4.
Yes, its power is even. But they're saying in the question that they don't want the ones where what? Let me do this.
Calculate the sum.
Yeah, calculate the sum of the first. Oh, no, wait. Consider the first 21 terms of the sequence. Calculate the sum of the terms in the sequence that are not powers of 4. So if they say a term is a power of 4, it's if the exponent of 2 is even, right? So um what they basically mean, this is not difficult if you like look at it in another eye. So they're saying n plus 2 must be even in order for it to be what? In order for it to be a power of 4. So if you look between 1 and 21, how many even numbers and odd numbers do we have? Okay, for starters, what's an even number?
Uh, since we start with 8, uh, I think there are 20, there are 11 even numbers and 10 odd numbers.
It's actually the other way
Um,
around. Because
No,
wait,
no,
they
it's
said
11 odd numbers, 10 even
yes,
numbers.
yes. We're going to have even numbers. There will be 10 of them, and then the odd number. Okay, odd numbers.
No, I think
There
they
will
are,
be
I think we are misinterpreting it. I think there are 11 odd terms and 10 even terms
yes,
because you
because
don't know.
between 1 and 21. I'm saying we have 11 odd numbers because remember the odd numbers it's 1, it's 3, it's 5, it's 7.
Oh, yeah, I
Wait,
get your point
1,
now.
3. Yeah, you see?
Yeah,
So we have 11 odd numbers. And then your even numbers, there's going to be 10 even numbers. 10 even numbers, 11 odd numbers. So do we understand the part that 11, yeah, the odd number, the even number?
yes,
Okay, fine. And then since well, now we're clear on the fact that wait, where's the question? Wait, no, I'm looking for the question here. Sorry. Okay, good. Okay, so since well, we have classified that we have 10 even numbers and 11 odd numbers. Terms that are not powers of 4 when n is odd. So we have to sum up those terms. Do you get
all
it?
those 21 terms.
All those 21 terms. Like for all those, no, not all those 21 terms. All those odd terms, just the odd terms, not the 20, not the entire 21, because we have to neglect the even numbers, because the even numbers they're going to give us powers of 4, but the odd numbers they're not going to give us the powers of 4.
But I have a question, but I took it from something like calculate the sum of the terms that are divisible, something like that. So, what if I calculate the sum of all the 21 terms, then I check the sum of the numbers that are powers of 4, then I say the sum of not powers of 4 is equals to the sum of total minus the sum of the powers of 4.
Sum of the total, sum of the total minus the sum of the powers of 4. That would be correct, I think, but I think you're going about it the wrong way, because if we know that 11 numbers for fact, they are what they are, odd numbers. So it means we just need to focus on these odd numbers, get the odd numbers sums. Do you get it?
Yeah.
yes,
Because we know, sorry, we know that our n will be what? It will be 11, right? Our n will be 11. And then the common ratio, because wait, go to your notes. I need you to see something on your notes. I think I saw it the other day. The notes, the I think Tandaloti, I sent them to you privately, ne? But they're written your, yeah.
yes,
Is it there though? Uh,
I don't have notes.
I'll send them. Wait, ne?
oh, which one?
The ones on the ones that I sent you.
Oh, okay. Should I resend on the group?
Mm, now I'll resend them. I just need to find them over here. Aren't you in the
Sorry,
group
what?
when I come on? Wait, now I'm looking for them.
Okay.
Okay. I can't find the thing on the group. But what I wanted to show you guys is that because we know that it's a geometric sequence of 11 terms, remember it's the 11 odd terms. Its sum, how you can get it, you're going to say Sn equals to A all into Rn minus 1, all divided by R minus 1, right? Whereby this A, it's the first term of the sequence, right? This n is going to be your 11 because this 11 is just the number of terms. And then this r is going to be your common ratio.
I can't see the
Remember that,
screen.
yeah? You can't see the screen.
Can you please write it down? It's jammed. Oh, yeah. We can see it now.
Okay, you see it.
Yes.
But
Okay,
there you wrote odd number 10. Oh, I didn't see 11.
even
I thought it
number.
was 10.
No, it's even number. So
I
because we
I
said, you see it
I
now.
thought I thought you wrote odd number as 10. I didn't so
Oh,
proper.
oh, okay. Okay, because we said let's write down the series, the sequence of the odd numbers. We said it's 1, it's 3, it's 5 going onward, right? So we know that our first
Yes.
term, what is it? It's number 1, right? So in order to find out the Tn of the first, remember the sequence of the pattern is given to us by this. So in order to find out what our first position is, what our A is going to be in terms of this sequence, we just need to plug it in here because they're saying that as much as we know that these are our odd numbers, right? We need to plug them in here to know what the term is going to be. So for the first one, you would say T of 1 plus 2, which is going to give you T2, sorry, 2 cubed, which is just what? 8. So this 8, it's going to be your what? It's going to be your T1. So your T1, it will be 8. Now let's go to T2. You know for T2, simple. What are you going to do? You need to plug 2 here. So you'll have 2 raised to the power 2 plus 2, which is going to be 2 raised to the power 4, which is just what?
16.
Which is just 16, right?
Yes.
16. Okay. So you have 8 and then you have 16. Wait, let me see. 16 divided by 8.
2.
Okay. Wait. What is our next common? Oh no, guys, I made a mistake. It's supposed to be 3 here. Because remember, our next odd number, it's not a 2, but a 3. Right? So it's supposed to
For our
be
second
3.
command.
Yeah, because it was a 1, because 1 is an odd number, and then we're supposed to have a 3 here. Do you guys see the mistake? I said 2 plus, I said 2 plus 2, which was supposed to be 3, because it's our next odd number. You see, right?
Yeah.
Oh,
So it's
so we
supposed to
input
be
the odd
2.
numbers.
Yes, you put the odd number because you're trying to find out the term that it's going to give you. So you're going to say 2 all raised to the power 5. What is 2 raised to the power 5? It's 32, right? So it will be a 32 over here. So we know that our T1, it will be 8. Our T2, sorry, this was a mistake. It will be 32. Now, because this is what a geometric sequence, in order to find R, which is this ratio over here, you're supposed to say T2 divided by T1, which is just going to be 32 divided by 8, which is just going to be what? If you say 32 divided by 8 on your calculator, it's going to give you 4. So now
Oh,
you have
yes.
everything that you can use to substitute in here because you know what your A is. Your A, it's 8. Your R, it's 4. And your N, it's 11 because we have 11 odd numbers, right? So do you guys see where I'm going at with this?
Yes.
Okay. So we will have, now let's just substitute now, substitute here. So we will have Sn, which is the sum of the geometric sequence. What is our first term? It will be 8 all into what is our R? 4 raised to the power 11 minus 1. So this is minus 1, close bracket, all divided by what? What is our R? 4.
Four.
4 minus 1. So our Sn equals 2. If you plug that into your calculator, 8, 4 raised to the power 11 minus 1, close bracket, uh, 4 minus 1. Ooh. What is it giving you guys?
Mm. 118 848
118.
84
This is question what, Kana?
2.2.4.
2.2.4. Okay, wait. Let me just go to 2. Okay, 2.2.4. Yes. And that will be your answer. That 1, 1, 1, 8, 8, 4, 8, 0, 0. This will be your final answer.
I think
Okay?
it makes sense for the odd numbers. I was not understanding where is 11 related, but now I can see because on the even numbers, which is 16, it can be written as a power of 4, which is 2 to the exponent 4. But 8 and
Yes.
32 are only 2 to the exponent 3.
Yes. So do you see it now?
Yeah, now I get it.
Okay. So now let's go to question 3. So question 3, what are they saying? They're saying given the sequence, right? So you're
Quadratic.
given, oh, it's a quadratic. So it's a, sorry, quadratic sequence. Remember, quadratic sequence is that one that has a general formula of an squared plus bn plus c, and it has what? A
Yes.
second common difference, right? So when you think quadratic, just think tn is equals to an squared plus bn plus c, right? And what else? I said second common difference. Okay. So what are we given? We're given 14, 9, 6, and a 5. So they're saying show what? This is 3.1. They're saying show Tn equals to n squared minus 8n plus 21. Let me just sit down. So if we have this over here, okay, we have 14, 9, 6, and a 5. So if you say 9 minus 14 on your calculator, what are you going to get? -5, right? And then if you say 6 minus 9, it's giving me -3. And then if you say, what, 5 minus 6, it's giving me -1.
One.
Now, if you say -3 minus, open bracket, -5, it's giving me +2. Now, if you say -1 minus, open bracket, -3, it's also giving me +2. So can you see that our second common difference is the same, which we mentioned over here, right? So
Yeah.
now, in order to find, what do you call it again? In order to find this, right, the general formula, you're going to say 2a equals to the last term. And then for this one, I think it's 3a plus b equals to this one, right?
Yes.
Right, guys? Like, okay.
Yeah.
Then for the last level, it will be a plus b plus c equals to this one. So now let's solve for this one. So you'll have 2a being equals to 2. You divide both sides by 2. You'll have a equals to 1, right? Then we come here. Then you have 3 all into 1 plus b equals to -5. So now you have 3 plus b equals to -5. So now you have b equals to -5 minus 3. So you have b equals to what? -5, 6, 7, 8. -8, right? And then you have a plus b plus c being equals to, what is this? 14. 14. Is it 14? Yes, it's 14.
14.
Yeah.
Yes, it's
So we have
14.
our a as, yeah, we then substitute a as 1, -8, plus c equals to 1, 4. If you add these two together, you'll just get -7 plus c equals to 14. And then therefore your c will just be 14 minus 7. Therefore your c will be what? It will be 7. Am I lying?
Yes.
No, I'm
Yes.
lying. It's supposed to be 14
So yes.
plus 7. Ne? Yeah. Yeah,
Can
not
you please
minus.
bring the can you please bring the notebook to the middle? Yes.
Is it okay like this?
Yes.
Okay. So we'll have C equals to 14 plus 7, which will just give us 21. So now you have your A, your B, and your C. You can just plug them where? Into this over here. So I get we said this is Tn equals to an squared plus bn plus c. So our Tn will just be what? What is our 1? 1. What is our a? 1. N squared
Or
minus 8n. What is the c? Plus 21, right? So therefore, Tn equals to n squared minus 8n plus 21. So you just proved the thing that they wanted from us, right? Now let's check what the next question is saying.
Can we please try it? I want to see something.
You want to try it first?
Yeah, can you please give me 4 minutes, even 3?
Okay. Okay. Um. Yeah, I'll give you 5 minutes. 33, 34, yeah. We'll. Yeah. Everybody try it. 5 minutes.
okay. Sorry, is I'm asking about the second formula 2a plus b equals to -5.
Which formula?
Oh, the one to get the second difference, the 2a plus
This one.
yeah 2a plus b you see equals to -5.
Oh, it's
Just below
2A,
there.
not 3A.
Yes, 2a.
Oh, okay.
A plus B equals.
Oh,
I saw the answer for B. The answer for B, you wrote -8.
how is it? Wait, let me see.
Isn't it -7?
Wait, let me check something over here. What question is this again?
It's to find
Three,
B then.
it's 3.1, isn't
Yes.
Wait. Uh, let me check.
Hello, ma'am.
Yeah.
I want to ask, do you have a friend
Ama Pele, let me ask you Kumalone. Let me tell her. Now it's actually 3A. It's not 2A plus B, ne? It's 3A plus B.
Okay. Okay. Thank you.
Natanoloj. Yeah, it's not 2A. The
Yes.
2A, it's over here. It's 2A equals to this, the first term of the second difference. Okay, Kumalo, you
Okay.
may
Thank.
speak. Sorry, I just wanted to rectify that with her. You were
I
saying,
thought
Kumalo?
about I thought about it. I'll WhatsApp you.
You WhatsApp me.
I wanted to ask, do you have any friend who is doing engineering? I want to ask some questions because I want to apply.
Yeah, I actually do have a friend that's doing engineering. Yeah, you WhatsApp me that question, ne?
Okay.
Yeah, no problem.
Yeah, I'm done.
Um,
I don't
okay.
know. Are you done?
Tandole, are you done? Or should we just do it
No.
flat? Or you're not
Can
done
you
yet?
please give me
Oh,
You'll
let
tell
me
us when
try
you're
it.
done, ne? You'll tell us when you're
Okay.
done.
Um.
Yeah.
So which question are we tackling? I was still fixing the error.
3.2.
3.2.
Okay. Okay.
The value of n is equal to each term in the quadratic, which term intervals.
You can explain it.
Okay. Uh, okay, who's the first one that will walk me through what they did?
Oh, uh, I think they say two consecutive terms of the
Yeah.
quadratic sequence have a difference of 33. Calculate the value of the larger terms. So what I thought is that two consecutive terms of a quadratic sequence, if they have a difference of 33, which means 33 lie on the arithmetic, because the first
Mhm.
difference of a quadratic is in arithmetic. So what I did, I started by finding the arithmetic the arithmetic general term, and I got 2n minus 7. Then I equated it to 33. Then I found the on which term does 33 lie on the arithmetic, and I got 15. So I know that if on a arithmetic it lies on 15, therefore this the larger term that have a difference of 33, it is 16. I said 16 squared minus 8 times 16 plus 21, which is equals to 149.
Okay. So 149. So you said you realized that the second term of, okay. So you're saying, because we have, let's say, hypothetically, ne? So we have T1, T2, T3. And you realize that this over here, this pattern, it's what? It's an arithmetic, right?
Yeah.
Okay. And then from this step, you said that what?
Since I know that 33 is a difference of the
It's the
quadratic
difference.
sequence, which is an
Uh-huh.
arithmetic, I found
Mm.
I started by finding the general term of an arithmetic.
Which
After
is
finding
Tn is equals to a
a
plus
plus
n
n
minus
minus 1
1
times d,
d.
then I found 2n minus 7.
Okay, wait. For d, you said that this d was what? 33.
Yeah, it is 33.
Okay. Okay.
So you will
Yeah,
say
you said you then
33.
what?
I say I equated 2n minus 7, which is the arithmetic general term of the sequence, and 33. Then I say 33 is equals to 2n minus 7. I transpose 7 and got 40 is equals to 2n.
Wait, let me just do this. Let me look at the question again. Sorry. Yeah, continue explaining, Askisi.
Then when I found that 33 on an arithmetic lies on the 20th term, I already knew that if 20 lies on the general term, I analyzed -5 and -3 on 3.1, and I know that if
Yeah.
-3 is a difference of 9 and 6, which means the largest term is 6. If let's say the terms were increasing, so
Oh,
therefore I said T21 is the is where we'll find the larger term.
okay, okay, okay. And what would be the value of T21?
I made a mistake. Let me check.
Okay.
Let me put on the calculator. 21. 21 squared minus 8 times 21 plus 21. 294.
294. Okay. Okay. That's correct, actually. Like very correct. Down to the T. Tandele, how did you do it? How did you get it?
Um, I, I, my first step was the same as these, but I couldn't continue because I was starting to not understand because I used the arithmetic um pattern formula, and then I added in the different. I added 33, and then I simplified the formula, and then I got Tn is equals to a plus n minus 34,
Mm.
and then when I substitute in the first term, my problem was I was thinking of on a because I
Yeah.
don't have the first term, so I added one to n, and then it
Okay.
was a plus, yeah.
Okay. I understand. Nah? Let's try doing it together and different is just to see multiple ways in which you can do this, right? So because you are given that Tn, wait, Tn equals to what? Equals to n squared minus 8n. After this, I'm going to send a paper similar to this one. Please do it because we're going to finish before time lapses. Please do it, then send it back to the group, ne? Because we're given this and we're told that the second difference between what? Between two consecutive terms. If they say two consecutive terms, they just mean T1, maybe for example, let me just say TA and TB. These are two consecutive terms because what they are following one another. Ne? This is one way to do it as well. So we have TA, we have TB. They're following one another. They're saying that the common the difference between the two is what? It's 33. So note that down. We know that if we have two terms, the first term will be what? T1. The second term, what will it be? It will be Tn plus 1. Right? Right,
Can you
guys?
please repeat that?
I'm saying we know, so we're given this, right? And they're saying that we have two consecutive terms. And they're saying that the difference between the two consecutive terms is 33. And what I'm saying is that if you have T1 and you have T2, two consecutive terms, they're given to us by Tn and what? Tn plus 1. Because the first one, it will be T1. The second one, it will be T2. In terms of position, this will be the first one and this will be the second one. And 2, it's really just n, which is 1 plus 1, giving you 2.
Okay.
Do you see what I mean here? Do you understand this?
Yeah. Yes.
Okay, fine. So now we know for a fact that they're saying Tn plus 1 minus Tn, it should give you what? 33. So in order to find out what our Tn is, what we can do, because we already know this function, right? We already know the general form of the function. So, sorry. So we know that Tn plus 1, it will be T2 in instance, and this one will be our T1, right? So in order to get what Tn plus 1 is, you need to now replace in this general term, replace n with n plus 1, right? So you will have n plus 1 squared minus 8 into n plus 1, right? Plus 21. When you expand this, it will just become let me just show you, it will be n plus 1. If you expand this into n plus 1, if you'll have n squared plus 2n plus 1. You can just do the classical, this, but it will yield this. So now what I'm saying is that you're going to have n squared plus 2n plus 1 minus 8n minus 8 plus 21. So now you'll just simply have n squared, and then you have minus 2 minus 8, it will be negative 6 minus 6n, if I'm not lying. And then if you have 1, if you have 21 minus 8 plus 1, it will give you plus 14. So this over here, it's your Tn plus 1, right? And now for Tn, in place of n over here, in place of n, you substitute n, meaning Tn is just what? It's just n squared minus 8n plus 21. So now in order to find Tn plus 1 minus Tn, you will just have this n squared, um sorry, you will just have this n squared, sorry, n squared, which is this one, minus 6n plus 1 4, close the bracket, minus, open bracket, n squared minus 8n plus 21, right? Because this is Tn minus, this is Tn plus 1 minus Tn, right? Eventually it will give us n squared minus 6n plus 14 minus n squared plus 8n minus 21. These two, they're going to cancel one another, right? Equals to, if you say negative 6n plus 8n, what is it going to give you? 8 minus 6, it's just what? It's just 2n. And then if you say, um, what is this? Sorry. What is this?
Can I ask
14.
what is the difference
Yes?
between what is the difference between Tn plus 1 minus Tn? Sometimes they put Tn minus Tn, Tn minus 1 minus Tn.
Tn minus 1 minus Tn. What? Like this? No, oh,
Yeah,
you're saying like it will be Tn, wait, Tn minus 1 minus Tn.
yeah,
This is okay, now Tn minus 1, it means you'd be subtracting from this. It's going to, okay, this one, it will be like if you have a T3 over here and you're just trying to say T3 minus 1. Let's say you want to put a T2 over here. Then you'll have T3, this Tn minus 1. If you were given that your n equals to 3, this Tn minus 1, it is going to yield T2, which will be the previous term rather than the next term. Because Tn plus 1, it indicates the next term. Tn minus 1, it indicates the previous term.
yeah, I understand. Yeah.
Oh, okay. So from here, we have plus 14 minus 21, which will just give us what? Negative 7. So we were given that the difference, because this is Tn plus 1 minus Tn, remember that? We were given that this difference is equals to what? It's equals to this over here.
Hold on.
So we can just set this Tn minus 7 equals to 33. So we'll have Tn minus 7 equals to 33. And then from Tn, we can just transpose this 7 to the other side. So we'll have 33
40.
plus 7, right? So you'll have Tn equals to what? 40. You divide both sides by 2, cancel. You will get your n as what? Your n will be
20.
Okay.
equals to 20. But from here, you are not done because they said what? Identify the larger term. So if they say the difference is what? It's Tn plus 1 minus Tn. When n is what? When n is equals to 20, it means that the larger term, even if you put it here, because they said n is 20, if you put it here, you will see that this is T20 plus 1 minus T20, which means the larger term is what? T21 minus T20. So the larger term will be T21. Do you see it?
Yes.
Because we got our n as 20, so now we just substitute in our n over here. Right? So we got our n equals to 20. No, sorry. We got our large term as 21. Then now we're just trying to find what the value of this 21 is, because remember this 21 is just our n. So now to find out what the value of this 21 is, you can just take it and plug it into your equation. which will now say, uh, which will now give us 21 squared, right? Close bracket, minus 8n, minus 8 into 21, plus 21, which will give us the answer that both of you guys got as 294. Quite long this way. You could have also taken it the way that you guys did it by equating it to an arithmetic, ne?
Yeah.
So yeah, but we
Yes.
all arrive at the same place. Let me see. Yeah, guys, we are done with today's class. Then uh okay, we're done with today's class. I'm going to send the another paper to the group. Please attempt it on your own and send the answers to the group as quickly as you can, because if you put it away now, you're gonna be tired by the time you try and do it. So just do it now, right? And Kumalo, also
So,
don't forget to send your question. Ne?
yeah. What about
Yeah,
3 point? Oh, you said you should attempt 3.3.
yeah. And we'll just discuss it on the group.
Okay.
Yeah.
Please don't forget to send a picture of your notebook, the
You
pictures.
want a picture? Wee. Are you gonna be able to remember what is what? I think
Yes, please.
just
I think it's better if you can send a picture, we can analyze.
you guys don't think it would be better if immediately after this I just post the video and then you can like go watch the video again.
Yeah,
Okay, that's
that is
it.
also
Yeah.
fine.
Okay, no problem. Let me do that net lar. Sure.
Yeah.
Thank you.